In the last lesson, we learned how event loop works. In this lesson, we will enhance your understanding by showing you a more complicated scenario, mixing macro and micro tasks. To avoid any confusions, just remember two things. First, throughout the entire program execution process, there is only one macro task queue. When there is nothing left in the macro task queue, the program execution will reach an end. Second, each event loop has its own micro task queue. In other words, every event loop will start its own micro task queue. After the current micro task queue has been cleared, the current event loop will end. Take a look at this program. We first knew the promise constructor and passed the executor function to it. This process is synchronous, which means the resolve function is synchronous and the console log statement behind it is also synchronous. If we console log the resolve function, we will get undefined because the resolve function does not return any value. But having undefined as the first output on the console table can prove that the resolve function is executed as the synchronous code. The then method, however, is async. It will be added into the micro task queue. Next, the JS engine will encounter the setTimeout function on line 11. It will execute the function and add its callback to the macro task queue. This callback is the first element in the macro task queue. Then it will execute the last console log statement. Now all synchronous codes have been executed. The JS engine will check the micro task queue and clear it. After that, the JS engine will check and clear the macro task queue. Next, let's make things a little more complicated. On line 4, we move the resolve function into a setTimeout function. In the then method, before the console log statement, we add another setTimeout function. What kind of result will we get this time? The program will first new the promise constructor and run the executor function. The setTimeout function on line 4 will be added into the macro task queue as the first element. Then, the console log statement on line 7 will be executed. The then method will be skipped directly. At this moment, the promise is in the pending state because the resolve function has not been invoked yet. As a result, the entire then method will be ignored. This is like attaching the catch method to a fulfilled promise. The entire catch method will be ignored. After skipping the then method, the JS engine will encounter another setTimeout function on line 16 and add it into the macro task queue as the second element. Then the JS engine will execute the last console log statement. Now, all synchronous codes at the global scope have been executed. The micro task queue is empty. The JS engine will now start the second event loop to clear the macro task queue. The first macro task will fulfill the promise using the resolve function defined in it. Now the promise has been fulfilled, the then method will be added into the micro task queue of the second event loop. Currently, in the scope of the callback function, there are no synchronous codes left, so the JS engine will clear the micro task queue. The then method will be executed. When executing the then method, the JS engine will encounter another setTimeout function and will add it into the macro task queue as the third element. The JS engine will execute the console log statement on line 13. Now the micro task queue has been cleared, which means the second event loop has been completed. Now the JS engine will check the macro task queue again. It will find the second element, which is the setTimeout function on line 16. It will execute it and end the third loop. Then the JS engine will check the macro task again and execute the third element, which is the setTimeout function on line 10. Now the macro task queue has been cleared. The program execution will stop. Let's run the program. We can see our prediction is correct.